Hello everyone, this is Bradley. Today I'm going to make this slow motion physics simulation using animation nodes. You can download and know more about animation nodes from the link in the description. Also, in the comments, I will pin a breakdown of this tutorial in case you don't want to listen to my wordy introduction. So let's start. Why do I make this tutorial? Why do I use an extra add-on called animation nodes? Because as far as I know, Blender has no inherent ability to make this animation in a convenient way. Please point me out if I'm wrong, because I really don't know how to make this work easily in Blender. A bad result will look like this. As you can see, all pieces explode at the time of contact. The reason is that all pieces are already overlapping each other. Any force can break their stationary status as a whole and so on and so forth. To make it work in Blender 2.8, I can do some keyframe to make sure their animation are triggered at different times. But this method is not a procedural at all, and it just feels awkward when I would like to change something. There are 4 methods to do this kind of animation as far as I know. The first one is fracture modifier. Unfortunately, it's not in Blender 2.8 up to the date I recorded this tutorial. You can use Blender 2.7 and export that to 2.8, but this sounds awkward. Also, it does not work with official release, and likely it will be released as another version or branch of Blender. I will still post a link to their channel in the description if you're interested in their work. It's actually cool, but I just didn't use that in my animation. Second one is bullet constraints. This has explained well by Blender Guru and many other tutorialists. But on the internet, I can no longer find this add-on, and I don't think this version will work well with Blender 2.8. The third one is that there is a tutorial to shatter a cup in an older version of Blender using game engine. But the Blender 2.8 seems no longer having these features, so no. The fourth one is animation nodes, which I have been using in this case. Animation node is basically a motion graphic tool in Blender. Again, you can download and know more about animation nodes from the link in the description. So let's start to do the actual animation. First, you need to install the animation node. Goes to Edit, Preference, and install the zip file you just downloaded, and it will pop up a choice of animation node. You just need to enable that. And second, the add-on that I will use is Cell Fracture. This is built-in in Blender, so you just enable that. You don't need to download anything. So this is fine. Another thing is that in this viewport, I have turned on the screencast keys. So all my shortcuts will basically show at the left button side of the screen, in case you are wondering. So let's start. I need to firstly build a cube and GZ to lift that, and then second plane. Enlarge that to almost infinity. This is fine. And then goes to face, snapping, GZ, snapping this cube onto this plane. Then this is good. The second thing I need to do is I need to let's delete the top faces and select the rest of the faces and extrude along normals. This button is very important, and we extrude inner. Because the fracture process is not procedural, so we just have to do so the thickness cannot be changed later on, so be careful about this step. And the second thing I need to do is to create 2 materials. I will name the one material as outside and another material is inside, so that after we fracture the object, there is a difference in its material. Then another thing we need to do is on the bullet. I will create a cylinder, move up the axis and rotate that, move to Y. I will decrease its size. I probably will select the top faces, GY to enhance that, and extrude on Y axis. And I will hit S and shift the Y so that it will only scale at X and Z axis, and this bullet has been done. You can also make a kind of low poly bullet In this case, I'm just going to make this very low poly for demonstration purpose. And also, I will select these top faces and Shift S, cursor to selected, and I will create another object. It's plane axis. You can create any of them, it doesn't matter. And I will call it a falloff. And I will parent this bullet to this plane axis, Control P, and object keep transform. So now this I can move this bullet, but it will move with this falloff. So this is the idea. I think we've done most of part, and I will create another collection called that bullet, and make this falloff inside of this bullet, and disable this cylinder. Also name that bullet, name the bullet into this bullet, and disable this entire collection so we do not see them. This is done. Then we can again work with this cube. Yes, to fracture that we need to use annotate pencil as a guide. So I need to use annotate pencil, and I just go to the tool and draw on surfaces, and the bullet will basically hit here. So I draw a circle and another circle, and the other side draw a circle, another circle. To create more variation, probably I can draw circles inside as well. You don't necessarily be perfect, you just as a guide. The exact mechanism for these circles to work is too hard for me to explain, but there are a lot of tutorials talking about how it works, or sometimes you don't need necessarily to understand mechanism, just it will just work. But if now we start to fracture these things, hit F3 and search cell fractures, and if you turn on the annotation pencil and fracture that, it will basically create kind of nice geometry at the places we draw these lines, but on left and right side it looks kind of it's not very good. So that's why we also need to draw several lines. It does not necessarily be perfect, just not to draw too much, otherwise too much focus will be otherwise too many lines will be too many pieces will be generated on the left and the right side. We just need to just a little bit, it will be fine. So now we can start to fracture that. The source limit, there are lots of options, and I'm not going to detail, but there are several things I want to mention. One is source limit. Basically, it means how many pieces you would like to generate. So roughly 100 pieces in this case. And the material is very important. Previously, we generated two materials. The index always count from 0. So the outside has an index of 0, inside have an index of 1. We need to assign the new faces to have an index of 1, which is the inside, and then hit OK. So this is our geometry. It looks better than previously. It's still not good enough, so you can probably add more lines at the left and the right side. In this case, I'll probably just call it over, or actually I would actually do more. And so I disable this collection, so it only tells me all the pieces. I'll hit N to bring up the basically what I want to do is to disable this annotation. I will keep the annotation in case I would like to tweak the field further, but now it's fine. So I have selected all the objects, and I will hit M to make them into collections. Fractures will be fine. And then we turn the collection back on. I will select the ground plane and add a rigid body. Set it to passive. Oh, also, here you can see the shading looks very weird. It's because the cube is overlapping with our fractures. So what we can do is to create another composition, just hidden, and put the cube in, and disable the cube. It will solve the problem once for all. You can also just hide that in viewport and render. If you don't see all these buttons, you can go through here and the restriction toggles. But I like disable this collection. That will serve better. And then now we turn on the bullet. We can start to work with the nodes. Previously, we just enabled the physics for the ground plane. And it will instantaneously create a rigid body wood, including a collection, which is also called rigid body wood. So we need to ask all these pieces having the same property as the rigid body would. I will explain, I will show you what do I mean. So we go to collection info and set it to fractures. And there's another node which is called collection operations. Object goes into object sockets, and we take this collection as rigid body wood. So now all these pieces now have a rigid body assigned to them, which is good. But the physics will actually not occur because I set the AV sync on. So now I play the animation, nothing occurs. But if I turn the AV sync off, then physics applies to that. It's basically because if you turn on the AV sync, the caching system will not work properly, something like that, or whatever. This is the idea. So if you turn on the rigid body wood, but nothing occurs, it's probably due to AV sync. Okay, so this is a trick. But now everything will explode. This is not what we want. We want to control all these things. So one thing we can do normally is to tweak the animate. The animate option basically decides whether this object will follow its transformed data or will follow its physical simulation. Because if it follows physical simulation, then it will just follow the gravity. So this is the idea. So if I'm turning the animate on, then it will follow with the transformed data, which means it will stay in place. And if you keyframe this animate, then it will fall down as the idea. But there are 100 pieces. I'm not going to do one by one. And I would like to set up a gradient. So that's why I need animation nodes to do that. Previously, we created a falloff. And I need to use this falloff as a guide. So in this case, I will firstly keyframe this falloff. I just go to location, hit I. And it goes to a place and just move GY, move along Y-axis. So it flies. And hit I again. So it will move. I want to apply a physics to this bullet. So I turn on the rigid body. But if I turn on the physics, then it will fall. It will not follow its transform data. That's why we need to keyframe this animate. So I will set animate first. And then at the moment where I think it actually collide with our object, I will turn this animate off. So basically fly in such a way, as you see. You can see the bullet is not going fast enough. That's why it does not inherit a good amount of inertia from the movement. What we can do in this case, just move that farther and keyframe that. So, and there are lots of things that you can tweak because it collide with this object faster. So at the 20 seconds. Yeah, this looks better. So I will stop here and start to work with the cube because it previously collided with the cube now. The next step we need to do is to use this falloff data as a guide to enable its physics, particularly the animate option. What I need to do is firstly a object controller falloff, and I will set it to directional and set the location as y. Or negative y. The issue is we are moving along the y-axis, and these particular numbers are actually meaning its local axis. So you can turn on its local axis, I suppose, in the viewport. Yeah, you can turn on the viewport display, the axis. So the direction it points is the positive. So now we turn on the positive y and select this falloff. Next thing is evaluate falloff, and we need to set it to location, and we need to compare the location of our falloff and the location of all these pieces. So I need a object transform input. Put all the objects in and the locations to locations. Because this is multiple location, but here is only one location, so I need to create a list so they can plug in. Otherwise, probably it will not work. So it will output a strength from 0 to 1 to determine whether all these pieces are in the range of its falloff. So this is the idea. So what we can do here is to loop through these strengths. I've just uploaded a video about the loop function yesterday, so you can know more about. So it's the ultimate reference why you use a loop. So I will not explain too much here. You can just follow what I'm doing, and it will be fine. Next thing I need to do is compare. Basically just and smaller equals to, and plug this float in and set 0.5. It just kind of cut half because the strength value goes from 0 to 1, so you can tweak this number. It actually does not matter. The point is, this result you can see it's actually a yellow circle compared to the blue or whatever colors. If you turn on the viewer, it will generate a number. It will turn to be a Boolean list. So if it's true, for example, this axis, if it's true, then it means I click. If it's false, then it means I'm not click. So this is kind of idea. And I will output the loop. This loop will be a Boolean list. So why I need to output with a Boolean list? Because I want to use this Boolean list to animate this animate option, which is also a Boolean. So to control, I will enlarge the view for you. So to control this animate, what we need, a node we need is copy object attribute output, and we put this object into this socket, and we need this attribute. So what we can do is right click this option and copy data path. So it will put the rigid body kinematic into this socket, and we enable the multiple values because we have multiple objects, and turn this Boolean list in. So now basically this falloff will work, although the bullet will actually not work well. So this is what happens. This is very cool actually. There's several things that you can change. one thing, the reason I made this falloff instead of bullet is I can offset this bullet GY, so that because the falloff may not reach the anchor points of all these objects before the bullet hitting, so the bullet will only hit the hard surface of our models. So that's the idea. So if I offset them a little bit, then these objects will more likely to collapse before the bullet hitting, and the bullet can just shatter them on time. Another thing you can do is simply to increase the mass of our bullet, maybe 500. And also we can actually, so let's play the animation first. So now the bullets can actually penetrate the entire thing. Another thing is, as we previously had been said, the velocity of our animation is not enough. So what we can do is simply shorten the animation, and basically it will be fine. So now this is the idea. Looks pretty cool. But our initial thoughts are actually doing a slow motion physics, right? So we go to the rigid body wood. You can actually turn down the gravity, and you can also turn this speed offsetting. So make 0.01, and we will keep the gravity first. So this is kind of the bullet runs too fast, but I think you get a kind of idea about this slow motion. There are many ways. So you might find it becomes very tedious to animate this animation option. So be aware that you can actually also create a falloff. For example, I can create a falloff at plane axis, like create a falloff here, and I will make it a bullet falloff, or animate and put it into bullet. And then I'm going to basically do the same thing. I need the object transform input and turn this bullet. Then I need to evaluate. I will actually just copy that. I'll turn the animate and turn the evaluate falloff. Turn off the list because we only have one bullet to control with. We can turn with these locations, and this is not the bullet. Yes, this is the bullet, and this is the animate, and turn this falloff on. And then we can compare the strength and even copy the object attributes, and even copy these object attributes, but we need to turn the object to bullet and turn this result in. So now instead of using a keyframe to control everything, so we can just delete this keyframe. It will always turn its animate on at this location. Actually, I think I did something wrong in this direction or such kind of things, but I think it's fine. Just to play the animation. Oh, it's not working because it's not animated. Okay, I need to turn -y. So in this case, I no longer need to concern about the animate option for these bullets. Even I just need to tweak the speed of this bullet, and it will be fine. Yeah, I think now this is basically, yeah, this now everything looks fine now. We can even turn down this bullet, GZ, and turn it down as well. Yes, this is very cool animation. I think this animation is very cool now. Is there anything we can do? Any other thing we can do? Oh, by the way, this is the fracture is not a procedural. So once it has been fractured, you cannot change the geometry. But the tree is procedural, which means I can change the direction of bullet hitting easily. One thing you need to realize is in this object controller falloff, it actually uses its local axis. As I mentioned earlier, the Y is point to that direction. So the falloff is also goes that direction. So if I rotate this falloff and goes to X, and now if I'm animate it's out. I need to clean all these keyframes first. And I animate like a flying in this direction. I will turn on these. I'll turn its motion path. So now you see the motion path has actually been aligned with its orientation as well. So now if its falloff will also change with it. So you can, I think this turns to be really cool actually. Although this is kind of very basic stuff that you can do in Blender, but I think this is really cool. Yes. I think this is really cool. Yes, I'm addicted on this destruction. What a fun. Yeah, basically that's it. You don't need to yes, I think basically this is done. To make all these kind of thing looks nice, at first I can start to texturing them. So basically a lot of things has been done. There's a lot of settings that you can actually work with, like even the softness of shadows, and yeah, lots of things that you can work with. I'm not going to spend too much time on this. Um, Here's just one thing I hope you to be aware is the setting of EV, screencast, refraction, even balloon population. No. In this case, I think this is nice. Probably this is too much. I can turn down the saturation, but make it darker as the ground. Yes, I think this is done. I hope you enjoyed this tutorial, and I'll probably see you next time. Ciao.